Students, let us start energy because work and energy are very closely related to each other. You have studied in lower classes also. There are so many different forms of energy. See the different forms of energy. Energy due to wind or food items or fossil fuels or firewood, whatever it is. There are so many types of energy. See the list of types of energy. These two are. They are mechanical energy, and we have to study mechanical energy, that is kinetic and potential energy, in detail. Rest all other energies are, some are renewable and some are non-renewable. These energies, let us talk about solar energy. What is the source of solar energy? Of course, sun. What about wind energy? What is the source of wind energy? Wind is there because there is temperature difference between the two zones, and that temperature difference is created by sun. So what is the source of wind energy? Again sun. Let us talk about muscular energy. What is the source of muscular energy? The source of muscular energy is food. Food you eat. From where does the food come? Food comes from the photosynthesis done by plant in the presence of sun. So what is the source of energy? Muscular energy is again sun. So let us discuss all these energies in small groups. Try to discuss and find out what is the basic source of energy of all these energies. That means, that is, you will find that the basic source, the ultimate source of all these energy is sun. But there is one energy, and that is geothermal energy. Thermal means heat, geo means earth. So this geothermal energy is the energy possessed by the earth due to heat of the earth. This is the only energy of which, that is, the basic source of this energy is not sun. This is the energy, and it is actually due to heat inside the earth and not directly or indirectly related to sun. And this heat energy is used to create steam and then to rotate turbine, then generator, and we can produce electricity with the help of this geothermal energy. These are some facts related to energy. Energy is defined as capability of doing work, ability of doing work. If you have energy, you can do work. The object which does the work loses the energy, and the object on which the work is done, it gains energy. This is also the fact that an object that possesses energy can exert a force on another object, and if it exerts force, that means it can cause displacement if sufficient conditions are provided to it. That means work is done. Thus, any object that possesses energy can do work. This is the meaning of the statement number 3. And the SI unit of energy is same as that of work, and that is joule. 1 joule is the energy required to do 1 joule of work. And what do you mean by 1 joule of work? 1 joule of work is that work which is, that is, when object is displaced by 1 meter, when the force is applied 1 Newton and it displaces the object in the same direction as the direction of force. So that is 1 joule of work. We have 2 facts here. That is, there are 2 types of mechanical energy, and which we have to discuss in detail. And first one is kinetic energy, second one is potential energy. Let us discuss kinetic energy first. Kinetic energy, this bow is possessing this arrow is possessing kinetic energy, this cyclist is possessing kinetic energy, these moving athletes are possessing kinetic energy, moving fan, moving car, everything which is in motion possesses kinetic energy. The kinetic energy, we will derive the formula, and from the formula we will get the fact that it depends on the speed of the moving object. Everything which is moving, see the examples, These all possesses kinetic energy. Let us find out mathematical expression for kinetic energy. We know very well that W is equal to force into displacement, and force is equal to M into A. What is this S? This S, according to third equation of motion, is 2AS is equal to V square minus U square. Acceleration, final velocity, initial velocity, and of course this is displacement. Substitute this S here, V square minus U square upon 2A. You will get this formula, M into V square minus U square upon 2. So this is work done when the object is moving and increasing its velocity from U to V. So work done is equal to the change in the kinetic energy of an object. Work done on the object, then it gains kinetic energy. I am doing work on this ball and this ball is moving. That is the energy gained by this ball, and that energy is kinetic energy. Where it comes from? It comes from the work done on the ball. If U is equal to 0, here U is equal to 0, then definitely we have the expression for kinetic energy, and the expression for kinetic energy then becomes K is equal to mv squared upon 2. Let us move to potential energy. Potential energy is the energy possessed by the body due to virtue of its height. See here. This stone possesses potential energy. How do you come to know? When this stone is dropped, it can damage a lot because it possesses so much kinetic energy. Potential energy. Now the potential energy is the energy possessed by the body due to virtue of its height. And one more thing is there, and that is the second type of potential energy, and that is due to its shape or configuration. That is also potential energy. But this type of energy which is possessed due to height is known as gravitational potential energy, and the energy possessed by the body due to its shape or configuration is known as elastic potential energy. Suppose we are talking about this spring. This spring has a particular shape. Now, when I leave this spring, it comes back. From where does this spring gets energy to move? Of course, due to its shape. Due to its shape and change, when we apply force, it changes its shape, and when we leave it, it comes to its original shape. It tries to come to its original shape. It moves. So this is due to elastic potential energy. Let us see the examples of elastic potential energy and gravitational potential energy also. First, let us talk about gravitational potential energy. When you lift a box up, it gains potential energy. Larger the height, larger will be the potential energy. This ball gains potential energy. This ball further gains potential energy. And of course, the second condition, this condition is having larger potential energy as compared to when the ball is here. Why? Because it depends on height. So let us calculate the gravitational potential energy of an object at a point above the ground, and let us discuss the formula. We have, let us lift this box up with the height h. So what is work done? Work done is again W is equal to F into S. What is F? This is F, that is mg. Mass of the box is m and the force due to gravity is mg. So this is the amount of force which is required here. Mg into the displacement is, when you calculate the displacement through height, that is known as h. So the formula becomes mgh. So when you are lifting something up, this box, this ball, when you are lifting this ball up, this will gain potential energy because I am doing work against gravity. to lift this ball, and that ball gains potential energy because my work gets converted into potential energy. So this is the expression for potential energy. The work done is mgh, and that work gets converted into potential energy, gravitational potential energy, and that is the expression for potential energy. Let us see this diagram. If you lift this box through h height directly, straight, this is path 1, and change the path, you move it like this. If you lift this ball through h height like this, and if you lift this ball like this, here, 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 but up to the same height, what do you think? Potential energy changes? No, because potential energy depends on height, not the path. It does not depend on the zigzag path or whatever path may be. If height is same, the two boxes have same gravitational potential energy. Here potential energy is mgh. Here also potential energy is mgh. It depends on your height. Larger the height, larger will be the potential energy. Because if you want to lift a thing, an object or anything up to a certain height, you have to do work. If you want to lift it up through a larger height, then you have to do larger amount of work. So we will gain larger potential energy when height is more. Then let us talk about elastic potential energy. Elastic potential energy is the energy possessed by the body due to virtue of its shape or configuration. The change in shape of a body can be brought by compressing. Suppose we compress this ball. It gains, that is due to its change in shape. It gains energy. This is elastic potential energy. By compressing, by stretching, by bending, by twisting this rubber, by bending, by twisting. There are so many things we can do, and due to the change in shape of anything like slinky or rubber ball or rubber band or anything, this work is done, and this work done is to change the shape of the body. It gets stored in the form of elastic potential energy of the system. This is, I am doing work, and when I leave it, what happens? It gains, that is, it moves, and it gains gravitational potential energy. That's why it moves. That is, when I leave it, that elastic energy gets converted into kinetic energy. See the examples of potential energy. This energy is water at the top of a waterfall. It stores energy. Water at the top of a waterfall has gravitational potential energy, that is due to virtue of its height. And this here, stretching a rubber band, it is elastic potential energy because it is due to change in shape of this rubber. Yo-yo, elastic potential energy. Drawing a bow, when you are extending the string of this bow, this is elastic potential energy, and the work done is stored in the form of elastic potential energy.